Okay, in this video, I will explain the workbook 3.2, question 9 and question 10. Question 9, question 10. Question 9, the function P of x modules the monthly profit in thousands of dollars from sales of a new product, where x equals 0 represents last month. So x equal 1 is this month, x equal 2 is next month. Question A, stretch a rough graph, roughly graph, graph the function. In the interval 0 to 24, how do you make your stretch? So first, I will find the x-intercept of the function. X-intercept means p of x equals 0. Okay, where where the graph intersect with x-axis. If p of x equals 0, that means this part equals 0. 0.84 times x plus 12, 1.2 times x minus 7.8 times x minus 18.6 equal 0. Okay. If the product of a set of numbers equals 0, then one of them must be 0. One of them must be 0, which means x plus 1.2 could be 0. This is one possibility. Or x minus 7.8 could be 0. Or x minus 18.6 could be 0. So that x can be negative 1.2 or x can be 7.8 or x can be 18.6. Y equals 0 when x equals these values. So this 3 point is our x-intercept. So it should be here, here, and here. 3 point. This point will be 18.6. This is 7.8, and this is negative 1.2. Then I want to find the degree of this function. Okay, and the degree that if you expand this function, it will be 0.84 x cubed. So x times x times x equal x cubed. So degree of the function is 3. So the graph might look like this when your leading coefficient greater than 1, or look like this when your leading coefficient less than 1. By the way, how to find the leading coefficient? If we have g of x equal maybe negative 2x plus 5, 4x plus 6 minus 6, and negative 3x plus 6, maybe x squared here, maybe a negative 2 in front. To find the leading coefficient, you found the product of all the coefficient of x or x squared. Find the product of this, and this. So leading coefficient equals negative 2 times negative 2 times 4 times negative 3. Because we have 3 negative, 1 positive, so the result will be less than 0, right? So the leading coefficient, which is a less than 0. Okay, this is how to find how to determine your leading coefficient is positive or negative. Just find the product of all the coefficient of x. Okay, and ignore the constant. Ignore 6, negative 6, and 5. Alright, for this question, the leading coefficient is is 0.84, so it's positive. So the graph looks like this. And there's no square, so all 1, 1, 1. So all the x-intercept is cross x-intercept. That means the graph will go straight through that point, will not bounce back. Okay, if you see a square, then it will bounce back. But here is all to the power 1. That means we'll cross, cross, cross. So you put this graph to here. it might look like this. Okay, so this is roughly draw the graph. What do the x-intercept represent? That represent the intercept between the graph and x-axis. So let's have a look. Okay. B used technology to find value of for the initial and found the product over the same domain. So initial, that means x equals 0. Also use your calculator. First you type this, and then use your calculator. Press second trace, and choose the first one, value, and type in x equals 0. The calculator will help you find the value of y. Okay, so that's how you found the initial profit. And the final profit, again, after you draw the graph, you press second trace, and the first one, value, you type x equal 24, or just type 24 and enter. So the calculator will show you x equal 24, y equals something. That will be your final profit, which x equal 24 is the final. Over the same domain, this is your domain, 0 to 24. So x 0 represent initial, 24 represent the final. Okay. What are the maximum and minimum profits? So again, if after you type the function, you use second trace. This time, if you want to find maximum, okay, find maximum, and you can set your left bound here. No, sorry, you can set your left bound closer to y-axis. Y-axis, yes, closer to. So this is your left bound, and set your right bound 24. 24 maybe is here, and then press enter. The calculator will help you to find the maximum and minimum profit. Okay, because I cannot show you the calculator here, so if you have any question using calculator, please come to me. Maybe I can show you in person. This is how to solve question 9, and then question 10. Consider the function this x minus b squared, x plus b squared, where x not equals 0. Identify the domain and range of the function. Okay. So, first I still want to draw the graph, right? So this is degree 4. So it could be a McDonald or W. The leading coefficient is 1, so greater than 0. So it must be this one, not this one. And the x-intercept, so x minus b squared times x plus b squared equals 0 when x equals b or negative b. So I have two x-intercept, one called b0, the other called negative b0. This is two x-intercept of the function. When you draw the graph, because it's w, so and this is square here, so the x-intercept is tangent x-intercept. Tangent, that means on here it could be like this, bounce back, or from bottom like this. But because our graph is w, so I think the graph look like this. Okay. So the domain is x belong to all real number. We have practiced how to find the domain of a graph from the graph, right? Domain is all real number. And range is y is greater or equal to 0. This is range. Okay, found the domain and range. Domain is x belong to all real number. Determine x-intercept x value of local maximum. So so local minimum will be this point. Okay, b0 and negative b0. Okay. In this function, the value of x, f of x, is always positive, right? Because something squared, this is positive. Something squared is positive. The product of two positive number is always positive. So f of x is always positive. And so the minimum value for y is just 0, 0. Maximum, it depends. It depends because with local, oh, there is a local maximum, right? I think it's just right in the middle. So you can plug in x equals 0 and found the value of y. There will be, if you plug in x equals 0, there will be negative b times b, so b squared is the coordinate of this point. It will be a local maximum. Okay, the y value of this point only greater than his neighborhood nearby. Okay, because some point here or some point here, the y coordinate is greater than this point. So you can only call this local minimum. And the number of turning points, I see 3. The first one here, second one, the third one we call turning point. Turning point is your slope from positive or to negative or from negative to positive. If you see the graph like this, there is no turning point even like this because the graph is keep climbing, keep going up. The slope is always positive. It never change from positive to negative. So there's no turning point for this graph. Is the function even, odd, or neither? Um, it's even. How can you tell that? Okay, first you can see from the graph, it's symmetry to y-axis. That means if you put the mirror in the middle, so the right side, the shape of the right hand side will exactly the same as the shape of the left hand side. So if symmetric to y-axis, then it's an even function. This is by the check by the graph. If you want to check by the function itself, you plug in f negative x into the function, into here. So you will see that will become negative x minus b squared times negative x plus b squared. So if you take negative 1 out, it will be negative x plus b squared negative 1 x minus b squared. You factor out negative 1. And then there will be negative 1 squared x plus b squared times negative 1 squared x minus b squared. And finally, you will get x plus b squared times x minus b squared. This is f of x. So the definition of even function is f of x equals, if this equals this, then we call even function. So this is an even function. From the equation, we know that is the even function. From the graph, it's symmetric to y-axis, still even function. So that would be even. Okay. Yeah. If you have more questions, please let me know. I will explain to you. Thank you for watching.